Written by Cheryl Snyder. Barely visible. A human hair, which is about 1/10 of a millimeter, 0.0039 inches in width, is one of the smallest things human eye can see. Imagine though if you could shrink yourself until your hair looked as thick as your heart. Imagine if the hair looked as fast as a tree trunk. What would you see? Hair on a flying lens would look like an enormous spike. The fly itself would look like a monster with gigantic eyes. Then the close-up view of a microscope provides. It changes how we see the world. The first simple microscopes. For thousands of years, people have been interested in taking a closer look at their world. The ancient Greeks used glass drops filled with water to make objects disappear larger. In the 1st century, the Romans discovered how to make in the middle and thin of the edges. The first magnifying glass when people started figuring how to make a painted glass lens in Europe. In the 1600s, the microscope was invented. At first, the microscope was just a sort of fancy magnifying glass. It had a single glass lid mounted at a holder for measurements. Most about 5 to 10 times larger in size. That was when the magnifying power of the first simple microscope. Compound microscope. Early microscope users figured out that they could put two magnifying glasses in line with each other to get even more magnification. The second lens magnified the image of the first lens, multiplying the power of the magnification. The second lens magnified the image from the first lens, multiplying its power of magnification. With the combination of two lenses in a single microscope, the compound microscope was born. The compound microscope total magnification is the product of the power of the both lenses. For example, if the first lens provides 10 times magnificent and the second lens provides 40 times magnificent, the specimen will be viewed at 400 times as its actual size. The compound microscope can magnify objects to make them appear up to 1,500 times larger than the actual size. Magnifies 20 to 30 times. One of the first earliest microscope users were a British scientist named Robert Hooke, who was improved the early compound microscope, which could magnify objects about 20 to 30 times of their actual size. He was also one of the first people to take detailed notes on what he saw through a microscope. Hooke published his observation in 1996 in a book called Micrographia. It was the first book on a microscope written by a scientist. In Micrographia, Hooke included drawings of close-up views of house loose of flea. He drew the compound eyes of a fly in greater detail than anyone had seen before. He sketched the individual hairs that covers a fly's body, the delicate antennae, and the complicated mouthparts. Hooke also sketched sections of plants and seeds when he examined a thin section of cork under a microscope. he discovered that it was made up of hundreds of tiny chambers. He described those tiny chambers as cells. They reminded him of those small rooms called cells used by moths in monasteries. Eventually, the term cell became used to describe the tiny building block of all living things. Today, examining the slices of plant, let us see how seeds are formed. It reveals how cells make up their veins and tissues for plant leaves. It shows that the cells that allow water and nutrition to move in plant system, which help us understand how plants live and grow. Magnified 50 to 200 times, historians believe that Hooke's micrographia inspired another early microscope user, Antony van Leeuwenhoek. Van Leeuwenhoek was a Dutch cloth merchant, not a trained scientist. However, he used magnifying glasses to examine the different types of fabrics he bought and sold. When he thought Hooke's drawing of the microscope worked, Van Leeuwenhoek started making lenses of his own. Van Leeuwenhoek did a way to create better lenses. As a result, he was able to make a microscope that magnified objects to more than 200 times their real size. He assembled more than 500 microscopes in the late 1600s and early 1700s. Using the stronger microscope, Van Leeuwenhoek discovered red blood cells. He also discovered tiny life forms called microorganisms living like water and scraping from someone's teeth. Before Van Leeuwenhoek's time, no one knew that microorganisms, living things too small to see with naked eye, even existed. Microscopes revealed that microorganisms live everywhere. Today, if you use a microscope in the classroom, you probably magnify objects about the same amount as Leeuwenhoek's early microscope. Although 200 times magnificent might not seem like a lot, it's enough to reveal detail invisible to the naked eye. Even something as simple as sand seen in new light under the microscope. Without magnification, the sand looks ordinary and plain. Under magnification, it's clear that the sand from the ocean edge contains microscopic shells, fragments, coral, and volcanic rock. Magnified 200 to 1500 times. Early compound microscope has some problem because the lenses often create distortion in the image. It was extremely difficult to tell what was the actual image and what was an artificial effect caused by a wet light path through the lenses. In the early 1800s, a British scientist named Joseph Jackson Lister invented a new type of lens that could be distortion problem. His work made microscopes more powerful and reliable. As a result, microscope allowed new discoveries in multiple fields of science and medicine. In mid-1800s, phrenologist Louis Potter discovered that the microorganism in the air could commit beer or milk, causing it to spoil. Around the same time, the improvement of microscope allowed physicians to see microorganisms in the body of sick people. For the first time, scientists made the connection between microorganisms and disease. This story revolutionized the practice of this medicine. This early compound microscope also led to the discovery that two snowflakes are alike. The discovery that two flawed American photographer Wilson Aunt Bentley, known as Snowflake Bentley for his work with snowflakes. He began a camera with his microscope in the late 1800s and early 1900s to take photograph more than 5,000 individual snowflakes. He showed that snowflakes are mirror images of themselves in 6 different directions. Compound microscope allowed scientists to discover that salt, sugar, and some other substances form a very crystal structure. Salt is made up of 2 types of regularly split atoms. As a result, it forms regularly shaped cubic crystals. Sugar or sucrose is made of 2 different simpler types of sugar. It forms crystals that are slanted at each end and more oblong than salt crystal. The ability to see the world's tiny details can help people understand how these things work. Take the cockbird. A Swiss engineer named George de Maistre became curious about cockbirds that stuck to his clothing and his dark fur, wondering how they attached themselves so firmly. He got a closer look at the bands under a microscope. He saw that they had tiny hooks that are latched to the loops in the fabrics of his plant. Inspired by the nature's hook and loop fastener, their method worked to create a design using fabric. Years later, the vision was Velcro. Velcro is made up of 2 pieces of fabric, one covered in thousands of tiny hooks, and the other covered in thousands of tiny hooks. The hooks and loops allowed the 2 pieces fabric to zip together. Modified 1 million times because of the way light works. There is a limit to how much magnification a compound microscope can achieve. During the last century, scientists developed microscopes that use different ways to eliminate samples, including ultraviolet light and beams of energy called electron particle microscope that use electron beams to illustrate samples that are called from electron microscope. They provide the greatest magnificence and the type of microscope currently in existence. They can merely assemble up to 1 million. Conclusion: with each new degree of magnification, more detail is revealed about the tiny structure of plants, animals, and materials. As a result, microscopes have allowed countless discoveries in every field of science. Microscopes make them visible, allowing us to explore in this world in an entirely new way.
Good job!